have a circuit with a resistor, inductor, and capacitor in it. They're not all in series. We have our inductor and resistor in parallel, our capacitors in series to that combination. So before the switch is closed, the capacitor is uncharged and all currents are zero. So the instant we close the switch, we want to find the voltage drop across each element and the current through each element. Well, the capacitor, what determines how much voltage drop a capacitor has?
The change in voltage. Or the voltage drop.
That's a restatement of...
0 equals 0 because...
So, physically, what is it that determines the actual voltage drop?
The current.
It's not the current. On the capacitor. What's the equation for delta V for a capacitor?
Q over C.
Q over C. So charge. If you have charge, you have a voltage drop. If you don't have charge, you don't have a voltage drop. Initially, the capacitor is uncharged. So the instant the switch is closed, the capacitor is uncharged. So it has no voltage drop. So it's behaving as if it were just a wire. Which is what you're saying. Loop rule. If I go through the loop here, the battery puts in a voltage of the EMF here. Capacitor has no voltage yet. So how much voltage does the resistor have? I've already done this.
Same voltage as the battery.
Yeah. The battery puts in the EMF and the capacitor is not taking any of it out because its voltage is 0. Then the resistor has to have the voltage of the battery. The inductor and the resistor are in parallel with each other, so they both have to have the voltage of the battery. And you can prove that to yourself if you look at the outside perimeter loop and look at Kirchhoff's loop rule. Now current, the inductor, the instant the switch is closed, the inductor is perfectly successful at that instant of keeping current from flowing through it. So there's no current that flows through the inductor. The current through the resistor, using Ohm's law, the voltage drop across the resistor is equal to IR, so I would be the voltage drop across the resistor over R. Well, according to the junction rule, whatever current flows out of the battery splits off at the junction. So the total current flowing from the battery is the current flowing through the branch that has the capacitor. It has to add up to be equal to these. So the capacitor also has E over R. Questions on that part? You good? So a long time after the switch is closed. By that, we're assuming the capacitor now has had plenty of time to charge. What is the maximum voltage this capacitor can reach? The EMF of the battery, exactly right. The capacitor will reach its maximum possible voltage, which is the EMF of the battery. If we look at the loop rule, if the capacitor has the EMF of the battery, what's left for the resistor? Nothing. Capacitor, when it's completely charged, does not takes up all the voltage for that branch there, and it does not allow current to flow. If no current's flowing through the branch with the capacitor, there's no current getting to the inductor or resistor either. So the capacitor ends up completely charged, it has the whole battery voltage, and it stops current from flowing in this circuit. Call that an open circuit. It's as if you had opened the switch. Questions? You good?